Hello and welcome back. In today's video, we'll be talking about the basic principle of self-aligning rolling contact bearings. So before we get into the details of the rolling contact bearings, that is the self-aligning rolling contact bearings. So let me just give a brief introduction to bearings and why they are used. And so bearings are the mechanical elements which will allow the relative motion between the stationary part and the rotating part. So either the shaft is the rotating part and the axle or the housing or the wherever it comes and sits, that is stationary part, and it will allow the relative motion. So it ensures the free rotation of the shaft with reduced amount of friction. So basically it is used to reduce the friction, and it also supports the shaft on the axle, which will help reduce the deflection, and also it will keep the shaft in correct position. So it will take up the radial as well as the axial. It will take up the axial as well as the thrust load. So these are the major things why we need the bearings. Okay, so bearings are classified into generally broadly. Generally it is classified into two types. That is, it may be classified into rolling contact and sliding contact. So rolling contact bearings, and this one is the second one is sliding contact bearings. Irrespective of the type of bearing, the main purpose is the same. The sole purpose of the bearings are to reduce the friction, to support the shaft, and to take the axial and the thrust load. So now let us assume that this consider this A image and this one as the B image. So this is the shaft, which is the rotating element, and this is the stationary part. Okay, so there's a small amount of clearance so that we can always very minute 1,000th of an inch. The space will be very less, such that it will be a thin strand of hair. So that is why their bearings are very much high precision, are highly precisely machined and very. In this case, in first case, that is the A, the axis of the shaft and the axis of the stationary element are perfectly aligned. Okay, so there is no misalignment of the shaft. But when it comes to case B, we can see that the axis of the shaft is treated by a degree of alpha with the horizontal axis. So the horizontal axis, that is the axis of the stationary element, and the axis of the shaft is treated. You can see it is treated by a degree of alpha. So what happens? It will come and hit the stationary element, which will not serve its basic purpose. That is, it will not allow the free rotation of the shaft. It will increase the friction. It will cause the wear and tear. Okay, so and it will drastically reduce the fatigue life of the shaft. So in order to solve this problem, self-aligning rolling contact bearings are introduced. So now let us see what is the principle of working. So there are basically two types of self-aligning bearings. That is self-aligning rolling contact bearings. So this kind, where the first row, okay, where it uses ball, is called self-aligning ball bearing, and the spherical row which uses rollers are called self-aligning spherical roller. So now in the image you can see that this curvature, okay, the center point of this arc coincides with the axis of the shaft and the stationary element, that is the bearing itself. That is the bearing outer race. Okay. So what happens is, when it coincides, it allows the relative motion. You can see that it allows the relative motion. So thereby allowing, thereby giving the misalignment. Okay. So in these cases, it will not rub against each other. Even now, it will be having some amount of clearance. Thereby, the self-align, that is the problem of misalignment, which leads to the wear and tear, is solved. Similarly, here the self-aligning ball bearings, it uses a point contact, so it takes very much less load when compared to self-aligning spherical roller contact bearings. So self-aligning spherical roller contact bearings take much higher radial as well as thrust load when compared to self-aligning ball bearings. So the major difference is that the why the self-aligning spherical roller contact bearings take up the majority of the load, more load, is because it uses a roller. Okay, so and it has a point. It doesn't have a point contact. It has a line contact. See, the roller has a point contact. If you use roller, it has a line contact. So line contact, so any line contact kind of bearings, that it may be a cylindrical roller bearings. It take when you compare with the that is the D group ball bearing, it takes up the generally more load because it has more contact area. That is, it is having a line contact when compared to the spherical. When you compare it with the spherical, it has having a point contact. So point contact bearings will have generally a capacity to take very less load when compared to line contact. So that is the basic principle of self-aligning ball bearings and self-aligning spherical roller bearings. So this is it, and thank you for watching my video. Please do like and subscribe my channel for more videos like this, and comment below for any suggestions. Thank you.